Welcome! In this series of short videos, we will give an introduction to those who have never used PowerBasic before, or even considered taking up programming. Today we will look at object-oriented programming. So what is object-oriented programming? Object-oriented programming, or OOP for short, is a computer programming model that organizes software around objects instead of functions and procedures. The concept of OOP is not new and has been around since the mid-1960s. Over the years, it has garnered both supporters and detractors for the concept. Like any programming module, it has advantages and disadvantages. And the model breaks down to 4 basic principles or pillars: abstraction, encapsulation, inheritance, and polymorphism. We'll come back to these, but first let's look at the advantages and disadvantages. So what are the advantages of adopting OOP? Modularity. Your code is contained in objects, allowing new applications to be constructed from pre-built modular building blocks. Reusability. Once objects have been created, they can be reused in future projects without recoding them. Flexibility. Objects can be replaced easily if the interface to that object is maintained. Maintainability. Once the interface to an object is documented, it becomes easier to maintain. Security. Provision of features that help protect data and control access to it improve your security. Widely adopted. OOP is widely adopted in many programming languages. So what are the disadvantages? The learning curve can be challenging for those new to object-oriented programming. OOP is not always suitable for all types of problems. Resource consumption. In some situations, it can consume more memory and CPU resources. Program size. There are often more lines of code in an OOP program, which can be daunting to new programmers. Execution speed. In some situations, programs can take longer to run. Extra design effort. More time is required to design an object-oriented program. While spending more time on design is not always a bad thing, it needs to be factored in to your project. So what are the main building blocks of object-oriented programming? Classes. A class is a blueprint for creating objects. It provides the initial value for states and implementations of behavior. The class defines the nature of a future object. You can interpret a class as a concept, while the object is the reality or the embodiment of that concept. Objects. An object is a data field with unique attributes and behavior. These are instances of a class created with certain data. Objects have the flexibility to correspond to real-world objects or abstract entities. Methods. A method defines the behavior of the objects created from the class. The method is an action that an object can perform. These are basically functions defined inside a class that determine what the object can do. Attributes. These are the characteristics of the class that aids in differentiating it from other classes and makes it unique and identifiable. So what are the 4 pillars of object-oriented programming? Encapsulation. A foundation pillar that protects data from unauthorized access. It's important to hide away data and code and separate it out. Encapsulating data within objects safeguards it from unauthorized access. Polymorphism. This allows a child class to have its own unique behavior while still sharing the same methods as its parent class. This allows for class-specific behavior and more reusable code. Inheritance, where classes can inherit properties and methods from other classes. The class from which you inherit is called either the base or parent class. Abstraction. This is a process of focusing on the essential features of an object, while hiding the details. It's a key concept in object-oriented programming, and helps reduce complexity and increase efficiency. So let's look at encapsulation. This is a fundamental concept in object-oriented programming that combines data and methods into a single unit called a class. Encapsulation has several benefits, which include maintaining data integrity. The protective layer around the data prevents unauthorized access, presenting a consistent interface. Developers can present a consistent interface that is independent of its internal implementation, enforcing rules and validations. The class can enforce its own rules and validations. For example, the body of a car or automobile houses the engine, transmission, and brakes. But you can interact with the car using its controls without needing to understand how these underlying parts actually function. Polymorphism. This is a feature of object-oriented programming languages that allows a specific routine to use variables of different types at different times. Polymorphism in programming gives a program the ability to redefine methods for derived classes. Inheritance. Inheritance is where classes can inherit properties and methods from other parent or base classes. Inheritance allows for code reuse and establishes relationships between classes. The derived class can extend the functionality of the base class from which it is derived by adding new features or overriding existing ones. This approach can speed up development when used correctly, but does involve planning out each of the classes and ensuring that any change you make to a base class doesn't have an adverse effect to the derived class. Some years ago, I was told a story about a military helicopter flight simulator in use in Australia, and the developers were asked to enhance it, as the helicopter crews were firing at anything seen moving on the ground, as they were obviously the enemy. So the developers added wildlife by creating a new class for kangaroos to make the simulator more realistic. Flight crews then had to identify what was moving on the ground before engaging it. On its first use, the crew ignored a group of kangaroos and flew on, and then were most annoyed when one of the kangaroos pulled out a weapon and shot them down. The new kangaroo class had been inherited from the soldier class, and a developer had forgotten to override the parts of the class that handled weapons. Abstraction. Abstraction is a core concept and is a process for hiding the internal data and implementation from outside. This allows the programmer to concentrate on a reduced set of data and functionality by creating application components. Objects are the building blocks of object-oriented programming. An object contains some properties and methods. We can hide them from the outer world through access modifiers. We can then provide access only for required functions and properties to the other programs. This is the general procedure to implement abstraction in object-oriented programming. There are two types of abstraction: data abstraction and process abstraction. When the object data is not visible to the outer world, it creates data abstraction. If needed, access to the object's data is provided through some methods or properties. We don't need to provide details about all the functions of an object. When we hide the internal implementation of the different functions involved in a user operation, it creates process abstraction. So, in conclusion, is object-oriented programming right for one of your projects? We have looked at the advantages and disadvantages of using object-oriented programming, and it will depend on the project you are working on, the number and skills of your developers, whether a switch from procedural code is a good idea. Object-oriented programming is well suited for large, complex systems with multiple entities and interactions. If your application is likely to be used only once, then a procedural code base is likely to be the best approach. It's also worth considering a programming language that can support both objects and procedural code within the same project. PowerBasic is one of those languages. Hopefully you have found all this information useful, but that's it for today. Thank you for watching.